After last day introduction, simply we can say what we are studying for the subject of thermodynamics. Now we are entering into thermodynamics. We study energy and its transformations in many industrial or domestic applications. That is what we are going to study in this subject. To understand this, first we will study all basic definitions with terms or words. We'll go through basic definitions. This is our lesson 1. System is the region in space where we focus our attention. That means system is a particular defined area that we are concerning or that we are paying our attention. Next, surrounding. It is the rest of universe, that means outside the system. Then boundary. What is boundary? The boundary separate your system and the surrounding. Then you can understand entire universe as system plus surrounding. More particularly, we can consider the surrounding as the immediate neighborhood of the system. Enveloping by the boundary. Systems may differ from one application to another application. So we are going to study different systems with different applications in industry and in the domestic applications. Let us see transfer quantities or moving quantities. We should identify these transfer quantities. Two things can be added or removed in a thermodynamic system. That means two types that you can add or you can remove from the system. Now you know system is there, boundary is there, outside you have the surrounding. Within the system you are having working fluid. Then in addition you can interact with heat and work both are energy. Okay. Now we are going to define another two important terms, process and state. So system changes its state from one equilibrium state to another equilibrium state due to a thermodynamic process. What is this? Look at figure. State 1 change to state 2, or state 1 is converted into state 2. How? by means of a process. Okay? Now, you can reach state 2 due to the process with another words. Again, you can say state 1 is transformed into state 2 due to a process. So in this figure, you can identify two states. One, equilibrium state 1, equilibrium state 2. You can separately identify. Then another process. Okay. Previous slide, you identified process and states. Then I will ask question. I ask question. How do you identify a state? Another word, how do you distinguish state 1 and state 2? Then you should have another term or another quantity or another entity. That's why we need property or properties. Now, so we can say states are defined by properties. So we can identify states by means of properties. What are these properties? Temperature, denoted by capital T, measured in Kelvin, that is one property. You can measure using a thermometer. And we use the units as Kelvin in engineering thermodynamics. Centigrade plus 273. You know this. Then next one, pressure. You can denote by capital P or simple P. You can measure Pascal, which is Newton per meter square. In industry, we measured in bar, BAR. Not a good place, but as a unit, bar is good. BAR, bar. Then kilopascal, megapascal. You can go ahead. Another property. What is it? Volume, cubic meter. We measured in cubic meter. So then enthalpy, capital H. You can measure in kilojoule. Internal energy, it's also measured in kilojoule. Another quantity, entropy, measured in kilojoule per Kelvin. So these properties are very important in order to understand or define particular state in equilibrium. Simply, if you want to identify a particular state, then you should know properties. Not all 6, but at least you should know 2-3 quantities, 2-3 properties. Example, if you want to define state 1 in the previous slide, then you have to say temperature at state 1, pressure at state 1, volume at state 1. Similarly, if you want to define the state 2 in the previous slide, then you should know temperature at state 2 T2, pressure at state 2 P2, volume at state 2 V2. So then finally what you can say? P1, V1, T1 is converted into P2, V2, T2. How? Due to a process. Similarly, you can see the variations of enthalpy, internal energy and entropy due to many processes that are taken place in industrial applications as well as domestic applications. I think it is clear to you. See, this is the summary what we have studied. I'm not going to read all these things. I'll give this thing for your assignment. Read yourself and remember and refer previous slides. This is a little exercise given to you. Okay, now we are doing very leisurely. I think waiting at home you are happy and comfortable. Now we are going little deeper and deeper towards the subject. This is very important. Now you are going to understand different systems. There are two different systems. You should remember this. Closed systems and open systems. Those are the basic thermodynamic systems that we should study. We will give you the definition. What is a closed system? Definition. A system in which working fluid remains within the system is called a closed system. Simply, this is the wording. If you ask a question, then you can write this. But you should understand what is this. What is this? What it says. Closed system. It is closed. The word closed. It is closed. Then you remember like this. You have the system, you have a boundary, and you have surrounding with our previous slides. Then you can understand physically like this. The most important thing inside the boundary means our system. The most important thing, matter, inside the boundary is the working fluid. If this particular working fluid is remained within the system without flowing, no inward movement or no inlet movement or no outlet movement. That means no interactions with the surrounding. It remains within the system. But the heat and work can interact. Heat can go in or out. Work also can go inward and out. It is possible. Simply you cannot remove working fluid to or from a closed system. But you can still add or remove work and heat. That means energy. Right? Shall I give a brief explanation again? In your words, the closed systems are such systems where the working fluid remain within the system, but work and heat can move inward or outward. So there may be different such systems in actual scenarios or in industry or domestic applications. Example, very simple domestic example I am taking. If you take a cool closed water bottle in a fridge, so that is example for closed system. Why? That you keep the water bottle inside the fridge, so water is not flowing outside. It's within the inside the bottle. Okay, the water is the working fluid which is inside the bottle, and out your system is the cabin inside the or the cold area inside the fridge. I think that is enough for the definition of closed systems. Okay, next is open system. How do you define an open system? Shall you define like this? A system in which working fluid flows across the boundary is called an open system. Work and heat can cross both in and out in addition. What is this? How do you understand an open system? Simply, in an open system, all these three transfer quantities, working fluid can flow inside or outside, heat can flow inside or outside, and work can flow inside and outside. All transfer quantities can flow inside or outside. Such systems are called unopen systems. Okay, I think it is very easy because the word open is open, right? Then your defined system can open for working fluid, can open for heat, can open for work. All three is open for in and out. Simply, you can add or remove working fluid to or from an open system. In addition, you can still add or remove work and heat. That means energy. I think you need another example for this. You take same water bottle with a cup. So then you can pour water from the bottle and drink. That means the water is the working fluid transferred to the cup. That means an example. So your working fluid is flowing towards the outside. So something like that. A very simple example, right? But industrial processes are little complicated. You will understand later. So for the subject of thermodynamics, we have to define or analyze these open systems as well as closed systems we have studied in the previous slide. Okay, then what we are going to do with this subject? We are going to analyze these open systems and closed systems with our transfer quantities. Simply, that is what we are going to do. I think you are going to understand subject little by little. That means we'll refer with previous figure which is in your mind. State 1 is converted into state 2 due to a process. This is taken place within the system with your working fluid. Then your process or your system may be a closed one or open one. In the case of open one, while the process is taken place, the working fluid is moving inside or outside. But in the case of closed system, when the process is taken place, it is not moving. It is remaining within the boundary. This is something in addition to the written content. You repeat the content and listen again. We'll see another system. Isolated system. A system in which neither matter nor heat can be added or removed is called isolated system. What is that? Simply, working fluid or heat cannot transfer towards inside or towards outside. Such systems are called unisolated systems. Example: a closed thermos flask can be considered as isolated system. Example: did you understand particular example? Thermos flask. So closed thermos flask. Then working fluid can't, hot water can't flow in or out. Then working fluid can't transfer. Similarly, it is thermally isolated with a vacuum and with the manufacture itself, with the thermos flask. So then it is heat resistance. No, heat can't flow out. Then it is a good example for isolated system. Further, we'll go for partially isolated systems also. Thermodynamically, we should know these things also. If you are told a particular system, if it is thermally isolated, what do you mean by that? If you are told thermally isolated, what is the meaning of that? In your particular system, if you take a particular system, in this particular system, heat cannot transfer. That means heat can transfer towards the inside or heat cannot transfer towards the outside. Both direction, impossible. It is thermally isolated. How this thermally isolation is done? How it is done? So there are refractory materials or heat proof or heat resistant materials are there. Then you can cover using those materials. There are fire bricks, refractories, and glass wool. There are many heat proof materials are there in industry. Cotton wool, so many. Right? Then you can isolate systems thermally. Then you can consider, or you can approximately consider, no heat transfer. Heat transfer is zero, in other words. Similarly, we'll think about another example, another application in industry as well as for our problem solving. If you are told rigid part or rigid vessel, what do you mean by that? Then from the terms or from the terminology, you should understand that if the vessel is rigid, the boundaries or the outer can't move. That means you can't do any work because work belongs to movements. Then no work done. Then simply work done is zero for rigid body or rigid vessel or rigid unit. It is isolated from work. It's another identification to this slide. It is more relevant with this slide. Remember this. You can replay and listen again if you can't understand. Cycle. What is this cycle? I think you can remember. So our summary, basic defining, when we are defining basic terms, so we missed cycle. What is cycle? How do you define a cycle? Yes, it is very easy. We'll see. You have initial state, then you have a process. After the process, you reach to state 2. Then at the end of state 2, so at state 2, then again you start another process, which is second process. So then you reach to state 3. Then another process and reach to another state. So on, you can continue up to the n or n minus 1 or infinitive. But how do we define our cycle? Then after a series of processes, you have to come back, like when you are coming to home, right? Isn't it? Then we can define a cycle like this. Initial state is regained or reached again after passing through at least 2 or number of processes. I think it is very clear. Initial state is regained after a series of or after many processes. You know that definitely you should have forward stroke and return. At least 2 processes, then otherwise you can't return. Okay? Then cycle is consisted with number of processes, at least 2. So you can understand entire nature or our nature. We can in our habitat, in our ecosystem, we can have many cycles. Mosquitoes life cycle, then rock cycle in geology or geotechnical, or in many religions, in Buddhism, like how is our mind and body transfer one condition by another condition until we achieve a particular state with zero entropy, like, or unit entropy, like, or something we can't define, we have not achieved. It's something else. If we again focus cycle, thermodynamic cycle is thermodynamic cycle can be defined as a particular, in particularly, initial state is regained after 2 processes or many processes, or initial state is regained after 2 or more processes. Okay, that's it. It's very important. Don't forget these cycles. We have many thermodynamic cycles. Future we have to study. Identify heat and temperature. This is to identify quantities. Heat is the random motion of the particles in the gas or your working fluid. That means a degraded form of kinetic energy. It can be considered as degraded form of kinetic energy. Everyone has a qualitative understanding of temperature, but it is not very exact, I think. The heat, how do you distinguish or separately identify heat and temperature? You may say the heat is the quantity with our own knowledge, measurable quantity. Temperature is a property with a temperature scale. That's true. But how do you feel it physically like? How do you do? How do you think it? Question. I'll ask question in order to understand this. Why can you put your hand in a hot oven and not get in, and not get instantly burned, but if you touch the hot metal rack, you do. That means you get burned. What is the reason? Simply, if the question is not clear, you say in a hot oven, just now cooking inside the oven, the very tasty uh, uh, cake is there inside. The particular person will say, myself, I'm very greedy, I want to eat it. I just open the oven and put my hand. But I don't touch metal parts. I touch only cake. Then my hand not get burned instantly. But if I touch the 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 metal walls of the oven, what happens? Sometimes my skin goes to the oven or burn. Huh? That is what. Then you can understand heat quantity absorbed in different materials. Some sort of idea. What the temperature inside and how the heat energy within that particular material or the particular body. That is what we should understand. Then you read the answer yourself and try to understand the difference between heat and the temperature and what it is. Okay. This is for you to understand heat physically. Oh, now we are very happy. Now we are reached to the end of the lesson. This is the summary. What you have studied. You study yourself. Oh, another summary. You too again study. This is for you. I expect that during this period you wait at home, comply to the government requirements, protecting our nation, and if you have enough time, go through two, 3 times, depend on your capacity and power of remember. Right? Study this and definitely you have questions from this PowerPoint. Okay, well done.